welcome back to our series on microservices and Apache Pulsar. In today's video, we are going to walk you through setting up a Django producer that sends messages to Apache Pulsar. We will explore the message flow in detail, ensure everything works smoothly, and dive into how to monitor the message stats on Pulsar. Let's get started. For this video, let's assume you have already set up a basic Django project. In my case, I created a Django project using a PostgreSQL database and have Dockerized it for easier management. To integrate Pulsar with Django, you will need to install Pulsar Client Library. I've added Pulsar Client 3.5 to my project's requirements file. For this example, I've built a small order application that includes three components: users, orders, and products. Additionally, I've created CRUD endpoints to manage the data for these components. To run Pulsar locally, we will use Docker. Pulsar provides an easy way to get started with Docker. This command will start Pulsar in standalone mode, making it ready for local testing. With Pulsar up and running, we can now start our Django producer service. Our producer service is now ready to publish messages to Pulsar. Let's test, does it work? We send a request from Postman to create a new user. Once the user is created, we trigger the send message to Pulsar function, which sends the message to Pulsar. To confirm that message was successfully sent, we monitor the message stats for the topic. In the command line, we see that a producer is created and a message is sent. If we also check the Pulsar admin console, we see the same. You can open the Pulsar admin stats at this URL. After sending the request, the MSG encounter increases by 1, confirming that the message was successfully published to the Pulsar topic. Pulsar messages are stored as unstructured byte arrays, and the schema is applied when the message is read. Both the producer and consumer must agree on the message structure, including field types. Pulsar schema defines how to translate raw message byte into a structured format. It serializes the data before publishing and deserializes it when delivering to consumer, ensuring consistency between producers and consumers. For this demo, I created a separate project called Pulsar Schemas to store the schemas for the order and user topics. This is based on the guide from the Pulsar documentation. Here I define all the fields that we want to send and consume. Ideally, the Pulsar Schemas project would be a standalone repository on GitHub. You can add it to your requirements like so: Pulsar schema at git repo URL. This way, both the producer and consumer can access the same schema. However, for the purpose of this demo, I copied the Pulsar Schemas project directly into both producer and consumer. Now, let's take a look at the real producer that we will use in our application. In this code, we have structured it to handle different topics like user and order dynamically. Let's break down what's happening in the code. We first set up logging to keep track of what's going on in our producer. This helps with debugging and understanding the flow of messages. We then initialize the Pulsar client using the connection details from our settings file. Based on the topic we are publishing to, we map it to a schema. We are using the JSON schema for Pulsar and defining two schemas, one for user and one for order. We have defined a producer clause that accepts a topic as an argument. This allows us to publish messages to different topics like user or order. We have implemented a context manager using Python's enter and exit methods. This ensures that the Pulsar client is opened when we start working with the producer and is closed when we are done. The send message method is responsible for actually sending the message to Pulsar. We pass the message to the producer, and if everything goes well, it will be published to the specified topic. We also handle exceptions and log any errors in case something goes wrong. The getSchema method returns the schema associated with that topic. This code makes it easier for us to produce messages to any topic we need, whether it's for the user or order topics. It abstracts the complexity of creating producers and handling schemas, so we can focus on sending meaningful messages to Pulsar. To ensure that messages are produced at the right time, when data is created, updated, or deleted, we will use Django signals. These signals will trigger message publishing to Pulsar whenever there are changes to the model. First, we need to enable the signals by importing them in our apps.py. Then in our signals directory, we import all the signals from the individual signal files in the init.py file, making them ready to be triggered. Let's take a look at the user signal. The receiver decorator listens for the post-save and post-delete signals for the user model. This means the signal will be triggered when a user object is either saved or deleted. The signal function checks if the user was newly created or updated, and it sets the action accordingly. Once the action is determined, the function creates a producer instance for the user topic and sends the message user data to Pulsar using the sendMessage method. This will publish the data to the relevant topic in Pulsar. If there is an exception during message sending, it's logged and re-raised to avoid silent failures. The instance to dict is a property defined in the user model that converts the model instance into a dictionary, making it easier to serialize and send a message to Pulsar. In this case, we only return the fields that are required, which are defined in our Pulsar schemas. Important point here. Sometimes schemas don't support all data types directly. This means we need to handle conversion ourselves. For example, in the order model, Django decimal field and data time field aren't supported in the schemas as is. To work around this, I've set total amount as a double and created that as a string in the schema. When preparing the data for Pulsar, we convert these fields and consumer will handle them accordingly. To ensure everything is working correctly, we test the message production by tracking the MSG encounter in Pulsar admin. First, we create a user from Postman. Once the request is sent, we see an OK status. In console logs, we notice the logs show action insert, indicating this is a new user. The logs show producer enter, where the connection to Pulsar is established. Then we see send user to MQ topic, which displays the data sent. Finally, producer exit confirms that connection is closed. If we check Pulsar admin, the message encounter increases by 1, confirming the message is successfully sent. To test updates, we send a request from Postman to update user details. We ensure the save method is explicitly called, not just update, to trigger the signal. A signal only fires on save and delete actions. In my setup, the save method is called within the serializer. Once the update is successful, the logs shows the action as update, determined by the created flag. In the Pulsar admin console, the MSG encounter increments, confirming the message is sent successfully. For deletes, we send a delete request from Postman. The logs display the action as delete. The Pulsar admin console again shows an increment in the MSG encounter, confirming the delete event is processed and sent to Pulsar. That's all for today's video, where we explored building a Django producer with the Apache Pulsar. In the upcoming videos, we will take it further by building a Django consumer service to handle messaging seamlessly with Pulsar. Don't forget to subscribe, like the video, and stay tuned for more exciting content to enhance your skills. Thanks for watching, and I will see you in the next one.